So here I'm asked to prove that the square of an odd number is always one more than a multiple of 4. And this question's worth 4 marks and it's a proof-based question, so I'm going to be looking to structure my answer really logically here, going through the steps and explaining what I'm doing and how I come to my conclusion. So initially here, I can see that we're working with the square of an odd number. Now I can kind of model any odd number in terms of an unknown variable. So the common one used here would be 2n plus 1. And that's going to represent any odd number. It can represent any odd number because 2n is always going to be even, a multiple of 2. And then if we add 1, it's always going to generate an odd number. Similarly here, we could have used 2n minus 1 or 2n plus 3, anything like that, but this is just going to be the easiest one to work with here. So I'm asked to prove that the square of an odd number, which we have here as 2n plus 1, so this is an odd number, we're asked to prove that the square of an odd number is always one more than a multiple of 4. So if I'm working with the square of this odd number, I'm going to start by squaring it. So if I take this and square 2n plus 1, I'm going to get the square of an odd number. So this is the same as writing 2n plus 1 multiplied by 2n plus 1, and then I can just expand out these brackets. So I'll do 2n times 2n, 2n times 1, and then 1 times 2n plus 1 times 1, using the FOIL method. So that leaves me with 4n squared plus 2n plus 2n plus 1, so 4n squared plus 4n plus 1 as this expanded bracket. And now if I'm looking to prove that this square, so this 4n squared plus 4n plus 1 is always one more than a multiple of 4, if I factorise out the 4 to get it in terms of a multiple of 4, I can then see what I have left over. So if I take this and take 4 lots of n squared plus n, and then I can add on this 1, leave this 1 separately at the end. Now this part of the expression here shows a multiple of 4. And then here I have a plus 1. So this is going to be 1 greater than a multiple of 4. So this way of writing the expression, 4 lots of n squared plus n plus 1 separately, is going to show that the square of an odd number is always one more than a multiple of 4, 1 greater than a multiple of 4. So I can just conclude by saying this is one more than a multiple of 4 as required. So now as for how the marks were awarded, the first mark would be for writing down an expression for an odd number, so 2n plus 1, 2n minus 1, anything like that. And then a second mark would be for expanding this odd number squared, so expanding these brackets and having at least 3 of the 4 terms there correct, which we do have. The third mark's for simplifying this, here in this line of working, to 4n squared plus 4n plus 1. And then the final mark is going to be for this concluding statement, so for writing that 4 lots of n squared plus n plus 1, and that's going to leave us with one more than a multiple of 4. And that's how each of the 4 marks are awarded for this question.